Welcome to The Explainer. Today, we're going to pull back the curtain on the internet's invisible highways and look at the actual physical hardware that makes everything go. So how does that actually happen? Well, it's not magic, even though it feels like it. It's really a story about some seriously smart hardware. And today, we're going to break down the key players that make it all possible. All right, so to really get this, we've got to go back in time a bit to the early days of networking. Back then, the main piece of gear was this thing called a hub. Okay, so imagine a town crier standing in the middle of a square, and instead of shouting the news, they shout every single private message for the entire town to hear. That's a hub. It's just chaos and super inefficient, right? Every single computer plugged into that thing had to listen to every piece of data, even if it wasn't for them. You can see how this shouting method would create a massive problem. It just clogs up the whole network, slows everything to a crawl. And that, of course, led to the invention of a much, much smarter device. So how do you solve a problem like a shouting network? Well, you get rid of the town crier and you hire a really smart postal worker. And that brings us to the network switch. Yeah, so unlike the hub that just shouts everything, a switch is like that postal worker who knows exactly where everyone on the street lives. It doesn't just dump the mail in a big pile in the town square. It delivers each letter directly to the right mailbox. But how? I mean, how does a little box know where to send all that data so precisely? Well, it uses a special kind of memory and a really simple but brilliant process that basically changed networking forever. So here's the secret sauce. The switch has this internal address book. Tech folks call it a CAM table, and it uses it to build a little map. It learns the unique hardware fingerprint of every device plugged into it. That's called a MAC address, and it connects that fingerprint to a specific physical port. So when data comes in, the switch just goes, I know who that's for, and sends it only to that one port. Your conversations stay private, and the whole network stays lightning fast. And switches are way more than just one-trick ponies. They are incredibly versatile. I mean, sure, they connect your PCs and printers, but they can also do cool stuff like chop up a network into smaller, separate virtual networks, super useful for different departments in an office. They can even send electrical power right through the network cable to power things like IP phones. That's a feature called Power over Ethernet, or PoE. Pretty neat, huh? Okay, so our local network is running beautifully now. It's efficient, it's fast, it's private. But what happens when you need to send something to a totally different network? You know, like the entire internet, right? Because a switch is fantastic for local mail delivery, but what if we need to send a package to another country? For that, we need a device with a whole different skill set. We need a router. The switch's authority kind of stops at the border of your local network. So if the switch is our local postal worker, think of the router as the big international airport. It's the thing that manages all the traffic coming into and going out of your entire network. It is your gateway to the rest of the world. Let's break that down because this is super important. The switch is the expert on the local neighborhood. It uses those physical MAC addresses to get data to the right device inside your network. But the router, it's the globetrotter. It uses IP addresses, which are like a global postal code system, to send your data between different networks all across the internet. They really are a perfect team. Okay, so we've got the key players, switches and routers. But how do the pros, the people who build these massive networks, actually design them? I mean, how do they talk about a super complex setup without getting totally lost? Well, they use a standardized set of symbols. It's basically a shared visual language that lets any network engineer, anywhere in the world, look at a diagram and understand the entire structure in a single glance. Think of it like a universal blueprint for building these digital highways. And it's really pretty simple. Engineers use this visual shorthand. A square box with arrows, that's usually a switch, the guy handling local traffic. See a cylinder with arrows? That's almost always a router, the gateway to the outside world. It's a clever way to turn a really complex system into a map that anyone in the know can read. All right, so we've covered a lot of ground. We went from that chaotic, shouting hub to the smart switch and then to the globe-trotting router. But here's the thing. This isn't just theory for big corporate networks. This whole evolution of hardware, it's all happening inside that little Wi-Fi box sitting in your living room. Seriously, that one device is actually a switch for all your wired gadgets, a router to connect you to the internet, and a wireless access point for your phone and laptop. It's like the quiet, unsung hero of your entire home network. So now you know the hardware, which is awesome. That's the first huge step. But what about the rules of the road? The actual protocols that guide every single bit of data on its journey across the world. Well, that is a whole other fascinating story, and we'll dive into that next time.